All right, I'm sure you're itching to actually get started and not just hear me blabber on, so that's exactly what we'll do. Before introducing the actual CAD drawing tools, we're going to first import a surface. As you've heard already so far, you'll be importing survey data of OHIL into the program, and we'll also are providing you with a satellite surface of the larger OHIL area. That way you don't have to spend 2 days surveying the entire field and the entire surrounding dorms and roads, and that way you're also not being put at risk of being hit by a car. That'd be bad. So that data, it comes from GIS data from satellites. If you're really interested in knowing how I got that into Civil 3D, I'd be happy to tell you in office hours, or if you want to email me. But we're going to go ahead and get started. The reason we want to do this is so you can get a good look at what this kind of 3D view space looks like. Before we can do anything, though, we need to assign a coordinate system. Right now, Civil 3D is working on base units, feet, 0 feet, 1 feet, 2 feet, 3 feet, kind of like an XYZ plane. But we want to assign a coordinate system to the space. That way, when we pull in the data, it is geo-referenced to where it actually is in the quote-unquote true position. So to do that, you can type in CS assign. This will bring up the way to assign coordinate systems. Geo coordinate system assign. And here you can see the selection screen. So if you haven't touched on this yet in class, the Earth is a sphere, or elliptical, oblong, ellipsoid, whatever you want to call it. The Earth isn't flat. And that's a problem when we're working in a 3D workspace, but it's still a flat workspace. So you might have learned about map projections before and how they always distort either size, direction, or distance, and this is no exception when we're working on computers as well. So what people much smarter than I did is they broke up the US into different state planes. So a state plane is a flat plane, so it doesn't account for the curvature of the Earth, but they're small enough that people have figured out that they're small enough that the error introduced from the Earth curving is fairly negligible and doesn't need to be accounted for. This makes it way easier to design projects and way easier to build projects in the field. But we can't just turn the entire US into a flat plane because that would introduce way too much error as you got farther away from that origin point. So let's see what one of these looks like. We're going to type in here VA 83-SF. So this is the Virginia State Plane South in square foot. So you can see all of that information here. And it's important that you're using the one in square feet and not in meters. And it's also important that you're using the south plane, not the north plane, because if we zoom in here, you can see that Charlottesville, where we'll be working, is covered in the south plane. So you can see here, people, again, smarter than I am, figured out that if you work in this area and turn it into a flat plane, the error in this distance from corner to corner is negligible in terms of accounting for the curvature of the Earth. Obviously, there is error, but they decided this is something we're comfortable with tolerating. So we're going to click this and click assign. There are state planes for every state. Virginia has a north state plane as well. A state like Texas or Alaska or California, way up here, have many, many state planes, and other countries use a similar system, but all in a different naming convention as well. Now, we don't need to assign an elevation coordinate. We'll be importing our elevation in feet, and Civil 3D will automatically recognize that, so we don't need to touch anything there. So if you clicked on the plane and clicked assign and OK, you're good to go. You'll now see a new tab appear on the top ribbon called geolocation. This geolocation tab is super cool because what it allows you to do is pull in map data from GIS or from Bing or like Google Earth and really see what the street networks look like, what the aerial imagery looks like. So if you come here and you go to map, this might take a while to load. You can pick any of these that you want to. I'll start with the Bing aerial view. You can see now that the Bing aerial view is on. Somewhere in this workspace, the entire state plane that we downloaded is in an aerial view. So we need to show you what that looks like, but to show you what that looks like, we need to find a way of finding that place. And a great way of finding that place is inserting geo-referenced coordinates. So we have that for you. Like I mentioned, it's the satellite data. So if you go to insert, This file is located on Canvas for you to download and import here. We're going to insert a land XML file. This is just a type of file. And navigate to your downloads folder or wherever you have it saved. And let's click on that O'Hill area contour file and click open. This dialog box is going to pop up. You don't need to do anything here. If everything is checked, you're great. If some things aren't checked, you can just check it and then hit OK. It might take a little bit to load, but now you can see we have a surface here, and it automatically took us to that surface in Charlottesville. So if you zoom in here, you can see that's Scott Stadium. That is Eway. This is Eway, and that's Olson right here. And this is New Dorms and O'Hill, the area that we'll be working in. So you'll only be surveying this area here for time and safety, but we wanted to give you data for the entire existing surroundings because we'll be doing some work on modeling these road networks that we have here. You might think this looks a little bit cluttered, and I would agree with you. If you go back to the geolocation tab, you can do something called capture the area. This one's really cool. It lets you draw a shape and capture that viewport and save it. Now I can go here and turn off the map, and the rest of my model space comes back, but that overhead imagery is still preserved here. Another thing you can do is now click on this image, and we can make it very fine if we want to, so increase the detail. And we can also increase the fade, so that way it's not overpowering everything we're drawing on top of it. The great thing here is that you can always access this again and just change the fade whenever you feel like you need to reference it. One thing I want to make a note of right now, and I'll remind you this again in the future, the data that you survey and the satellite imagery will not line up perfectly. So for example, even just this satellite imagery and the satellite data, you can see here that there's very clearly kind of a road here, but in the imagery, the road is over here. So you can see there's this offset between here and here where we think the road should be. So the imagery is a great guide for you, but it should not be how you reference or make your absolute final design. So I recommend keeping the fade fairly high. Use it to orient yourself, but don't use it to make your full design. Just to go over some basic navigation controls, if you're using a mouse, you can hold the scroll wheel, press down on the scroll wheel, and that will let you pan around. If you click on any object, you can hit escape to get off of it. Right-clicking gives you all of your editing options, and single-clicking on the left mouse button lets you draw to select objects. So if I draw a whole rectangle around this, for example, I can select all of the objects there. Left-clicking can also work on any individual object, and you can click all of those individual objects as well. And you can also scroll the wheel in and out to zoom. Another really helpful command is zoom. Type in zoom. You can see all of these different options, but extents is the best one. You can click on it or type it, and it zooms you into everything you have in your project space. So if you ever get lost, for example, go way over here, and you have no idea where your stuff is, you can type zoom extents. Z is a shortcut. E is a shortcut. So Z, enter, E, enter, and you can get right back to where you were working. Super, super helpful. I use that all the time. Now, another thing we're going to do here really quickly is clean up this surface. So we imported the surface. You can see it here in the Prospector tab. If we expand surfaces, you can see the surface here, and it has a bunch of different things and a bunch of different properties. We'll go over all of this in time. But right now, we imported the surface and we imported all of these contour lines. So contour lines, if you remember from any geography class you've taken, or maybe Calculus 3, contour lines show change in slope or elevation. So going directly perpendicular to a contour line means you're changing your elevation. Going parallel or longer contour line means you're staying in the same elevation. But right now, all of these contour lines are showing, and we don't want that. And one of the very, very powerful things about Civil 3D is the ability to assign and manage objects in layers. So in the Home tab, if you go all the way to the right, you can see all of the layer controls. If you click on this drop-down, Civil 3D natively has many, many layers. One of the neat things about these layers is that you can isolate them, turn them on, turn them off. You can lock them so they can't be edited. and you can change the view of them. So you can change the color, the line width, you can change the point type, the line style, text style. The layer kind of contains all of that information, and it makes it an easy place to edit a bunch of similar items at once. So what we're going to do right now is click the off button here, and this is going to turn off any layer we select, and just click any of these contour lines, the 3D polylines, and select them, and you'll see they have now been turned off. It says it down here, and everything looks a little bit lighter. So the surface that we imported natively has those contour lines in it, so we don't need to show them twice, and having them there would just make it really hard to click around. You'd be clicking on contour lines for days. So we just got rid of it. But know that that is a layer in here. You can always turn it back on if you ever need it. For now, though, this surface is what we're going to be working with. The last thing I want to show you is about drawing order. If you click on the surface, for example, and right-click it, there are basic modify tools, which we'll go into, and display order tools. It's very common for you to be doing work in Civil 3D and all of a sudden not be able to see what you're working on, and it likely has to do with the display order or if you have a layer turned on or off. So to demonstrate the display order, I can just take this surface and click send to back, and now you can see the surface is underneath this image. And so that's not great, obviously, so what we can do instead is also take this and send this to the back, and now that the surface is back on top. You can also use Control Z to undo any of your actions, or I think it's Control Y to redo. And that is another way of kind of undoing any mistakes you might have made. All right, so congratulations, you've imported your first surface, you've made the map view, and the last thing I want to show you is what this looks like in 3D. So as I mentioned before, this is a 3D viewport. So you can click, for example, any other corner you want to, and you can see, if I hit escape, this is a 3D surface. So I can zoom around, and here I can click different viewports, and you can see that there's elevation here. I'm looking at it directly from the side, and this is a full 3D surface and a full 3D program, and that is the power of Civil 3D, is it allows you to do that 3D design on a computer. And the other way I want to show you this is if you click on an object, there's an object viewer. This object viewer is a little bit slow, but if you click on it and open it, you can view your full object in 3D space very easily. You can zoom in, you can click on predefined views, and there's also different drawing styles. So for example, you can see here, they're shaded, makes it look really smooth, almost like it's an image from Mars, and there's 3D hidden, so that it shows you the outline, wireframe, shows you all of the different contours and triangles that Civil 3D uses to build a surface, and X-ray allows you to see anything behind it. So yeah, a lot of different styles you can use to look at your objects in 3D, in Civil 3D. And sorry, there's a lot of information here, we'll go over it again, but the last way you can view an object is, this is new. Instead of the object viewer in Civil 3D, you can use the model viewer. If you click add to model viewer, it'll open a new tab. I think the model viewer is infinitely better than the object viewer. The object viewer can get really slow on your computer. The model viewer has been really well optimized, so it's really fast. And one of the great things about the model viewer, which you'll use this later in this deliverable, is you can set views and save images, pan, orbit, and it has a full object hierarchy, so you can turn off and turn on objects. So that concludes this part of the tutorial. In the next tutorial, we're going to go over all of the basic drawing tools Civil 3D has to offer.